Good morning. Myself Pramod Kumar Srivastava, Professor, TMIT, TMU. My subject is Business Research Methodology. In this Business Research Methodology, today I am going to discuss on the measurement of the central tendency, the different measurement of central tendency, mean, median, mode, properties, advantage and limitation of mean, median, mode, or computation of the measurement of the central tendency in a grouped or ungrouped data. So this is the table of content of the class. Next is the learning outcomes. So after going through this lecture, you will be able to understand to explain the concept of the central tendency data, describe the different measurement of central tendency, mean, median, mode, and discuss the properties, advantage and limitation of mean, median, mode, and complete measurement of the central tendency for grouped or ungrouped data. So these are the outcomes of this lecture. So next is measurement of central tendency. So suppose we have a data, for instance making a psychology, obtaining the student of 12 years, 12 standards student, and you want to analyze it statistically. What statistical technique will you employ? You can of course organize the data with the help of the classification of the tabulation that we discussed in the previous unit, and can also be graphically represented. But if you want to further analyze the data, then you can compute the average marks obtained by the whole class or find the midpoint of marks above and below, which will lag half of the students, or you can also find out the most frequent marks obtained by the student. The technique are implied here are mean, median, mode, and these are called the measurement of the central tendency and can be categorized under the descriptive statistics. So measurement of central tendency categorized in a descriptive statistics. We are discussing about the classification, tabulation, and also graphical presentation of data. In the present unit, we will discuss the measurement of central tendency by mean, median, mode. We will not only understand what these techniques are, but will also focus on their property, advantage and limitation. We will also learn how to compute mean, median, mode for the group or ungrouped data. So simply, the central tendency means we have to know the central idea of the data. So measurement of central tendency provide a single value that indicate the general magnitude of the data. This single value provides information about the characteristics of the data by identifying the value at or near the central location of the data. So simply, the measurement of central tendency giving you a single value about the data. In another word, we can say that the measurement of central tendency as a summary or the figure that help in describing the central location of the certain group of scores. So simply, whatever the information or whatever the score of the groups that give you a central location, that's why it is known as the measurement of central tendency, or in short, the average or typical value of the item in the series, and its function is to summarize the series in terms of the average value. So in simply, we can say that measurement of central tendency is the average value of the whole data. Next is the main function of measurement of central tendency. So there are various functions of the measurement of central tendency. One of them to provide a summary figure with the help of which the central location of the whole data can be explained. So measurement of central tendency give you average location or average data regarding the whole information. Then we compare our average of a certain group, we get an idea about the whole data. So by getting the average of a certain group, we can get the idea of the whole data. And the second function is the large amount of data can be easily reduced to a single figure. So it is very important thing in measurement of central tendency is that the size of the data we do not know. Sometimes the data size is as huge as, sometimes it is very uncomfortable to manage the data, but through the measurement of central tendency we get a single value of numbers of data, and through single value we can get an idea. Like in the example of the measurement of central tendency, the per capita income. We know that the population of India is 140 crore, and the per capita income of that getting to that 140 crore divided the number of expenditure or the income divided by the number of population, and that's we are getting a one single figure for the whole population. So it is how it is important and how we can get a certain central idea of such a huge population. So large amount of data can be easily reduced to a single figure. Mean, median, mode can be computed for a large data, that is the single figure data. So simply the size of data might be any numbers, might be in crores or any numbers, but we can get a single figure. So measurement of central tendency provides you a single figure of the data. When mean is computed for a certain sample, it will help to guess the population mean. So if you are getting a mean of the certain figure, it help you to get the mean of the population. So next slide is the result obtained from computing measurement of central tendency will help you making a certain decision. This hold true not only to decision with regard of research, but could help application in various areas like policy making, marketing, sales, or decision making, or anywhere, any walk of life. So by getting a single figure of your group of the population or the whole population, and that gives you an idea to decide about the population or decide about the decision making situation. So obtaining it is very important for decision making process. So next is the comparison can be carried out based on the single figure compared with the help of the measurement of the central tendency. For example, with regard to the performance of the student in mathematical test, or the mean mark obtained by the girls or the mean mark obtained by the boy can be obtained. So simply if we want to gather a performance of the student, just we are getting a single figure through the measurement of central tendency, and we get an idea. And sometimes we divided the student between the genders of female and the male students. Also we can gather the central idea of the students male student marks or the female student marks. So measurement of central tendency giving you a huge opportunity in any walk of life. Through this we can manage, or we can understand that what is the certain remedies or certain requirement to complete whatever the achievement you want to complete. So measurement of central tendency give you a very good idea to understand about the population through a single figure. Next slide is good measurement of central tendency need to have the following characteristics. So there are for certain following characteristics for the good measurement of the central tendency. It start with the definition of the central tendency need to be adequately specified and should be clear. So whatever the definition of the central tendency, it should be specified and clear. It should not be subject to varied interpretation and the need to be unaffected by any individual bias. So whatever the definition you are decided, that should not be varied on the situational basis. It might be the situation depend upon the time situation or decision depend upon the individuals, or situation depend upon the geography. So whatever the situation, it should not be differentiated and there should not be any biasness, or that should not be related with the human biasness. The definition should be rigid so that the stable value is to obtain that represent the data. So if the situation is stable, we can obtain a representative value or represent a stable value. Second, the measurement of central tendency should be easy to understand and easy to compute. So second important characteristics of measurement of central tendency, it is easy to understand and it is also easy to calculate or compute. It should not involve elaborate mathematical calculation. So measurement of central tendency do not involve complex or elaborate mathematical calculation. It is very simple calculation, and significant number of the people can do this kind of mathematical computation. Just they have an idea of the divisions. So third point is the value obtained from the computation of measurement of central tendency to be representative of the data. The value data need to be computed. So measurement of central tendency, the data getting through the measurement of central tendency, it is a representative of the data or the representative of the whole population from where we are computing the data. So simply we can say that mean, median, mode, whatever the calculation of the measurement of central tendency, it is the representative of the whole data or the whole population. From there we are calculating the measurement of central tendency. So simply we can say that it is a best representative of the whole population or whole group of the data where we are computing the measurement of central tendency. And the fourth point is the data need to be collected from the sample that truly represent the population, and the sample thus need to be randomly selected. So whatever the sample we are getting through the population and calculating the measurement of central tendency, it is also true representative of the sample mean as well as the population mean. So these are the characteristics of the measurement of central tendency. Further, there are further characteristics of measurement of central tendency is the measurement of central tendency need to display a sampling stability and should not be affected by any fluctuation in the sample. So whatever the calculation we are getting through the measurement of the central tendency, it should not be fluctuated by the sampling. If there is a fluctuation in the measurement of central tendency due to getting a sampling, means there is a default in getting a sampling process. For example, if the two different a researcher obtain a representative sample from the same population, and the mean computation by them is should be the representative sample should display least variation. So simply we can say that if we are gathering a sample from the population, and the gathering process of sample from population with the various researcher, the mean values, there is no variation in the measurement of central tendency, either getting gathered by the researcher 1 or the gathered by the researcher 2 or the gathered by the researcher 3. If the mean value or the measurement of central tendency value is same by the every researcher, that means they are drawing sample from the population in a very better manner, and there is no default from drawing sample from the population. But if the measurement of central tendency value is differentiated by the each researcher, that means the from the same population, that means they are gathering the sample from same population. The drawing of the sample from same population is a way or the method they are using is the default method, and due to that default method there is the differentiation in the value of the measurement of central tendency. The next, the measurement of central tendency should not be affected by the outliers, or the outliers are extreme value in the data or the distribution. So whatever the value we are gathered, that should not be differentiation. So last one, that is not a list one, the measurement of central tendency should render itself to the further mathematical computation. So finally we can say that the measurement of central tendency rendered itself to the further mathematical calculation, and we are also using the measurement of central tendency for the further mathematical calculation. So it is also valuable for the further mathematical calculation. Next is the different measurement of central tendency. We already go through, there are the various measurement of central tendency. Here we are going through the measurement of the central tendency. The concept of the central tendency is now clear. We will now process to discuss the three measurement of central tendency. Three measurement of central tendency are here as follows. First one is the mean or the arithmetical mean, second one is the median, and third one is the mode. So here we are going through the three type of measurement of central tendency: mean, median, and mode. First go with the mean or the arithmetic mean. So mean for the sample is denoted by the symbol m or x bar. So simply when we are talking about the mean value, that mean value is denoted by the capital letter M, or it is also denoted by x bar, and the mean for the population denoted by the mu. It is one of the most commonly used measurement of the central tendency, and it is often referred as in the average. So simply there might not be any confusion with the measurement of central the mean value or the arithmetic mean value or average. All these three nomenclature is used for the same purpose or same meaning, but just we are discriminating. X bar is in the sample mean and mu is in the population mean, but the arithmetic mean or the average or the mean is the same nomenclature we are using for the population, or also we are using for the sample. It can also be termed as one of the most sensitive measurement. So we are also say that the mean is one of the most sensitive measurement under the measurement of central tendency, and the importance, utility, and scope of the mean value is immense in statistics. Statistical techniques can be computed based on mean, thus making it the mean more useful. So simply we can say that, so there are so many mathematical calculation or statistical calculation that it will be calculated on the base of the mean. So mean is one of the base value in the statistical field or in a mathematical field. So measurement of, under the measurement of central tendency, mean have a very high priorities for everywhere for the further mathematical calculation or statistical calculations. Mean is a total of all the score in the data divided by the total number of score. So for example, we can say that the calculation of mean value is, if you want to calculate the marks of the 100 student, so first we have to gather a marks of all 100 student and add on that marks of the 100 student and divided that marks with the 100. So finally we get the mean value of the marks of that 100 student. Suppose there is the 60 student in the class and I want to calculate the mean value of the mathematics marks of the student. So first we have to gather the mathematics marks of the whole student in the class. Suppose there is the 40 student in the class. So we getting all 40 student mathematics mark and adding all 40 marks, and whatever the total number we got, and we divided that total number with the number of a student in the class or the number of the student have got a mathematics mark scoring. So that suppose if the total number is 4000 and we have just 50 students, so we have divided 4000 divided by 50. So total marks calculated, whatever the total value calculated, that is called the mean value. So next is the median. Median is a point in any distributions below and above which. So simply we divided whole data into the bigger than that value or the smaller than that value. So that value is considered as the median value. Means the median value is the value or the single scored value of the whole data, and the whole data certain value is less than that value and certain value is the more than that value, and median stands for the mid value of the whole data. So simply median point in any distribution below and above which lie half of the series. So simply median is divided whole data into two parts. One part is the below that value and another part is the above that value. Median is also referred to as a P50. King's or minimum 2008 recommended that symbol for median is MD and stated by the Wardens and the Abbott in 2011. Median is a middle score in an ordered distribution. If we take the example discussed earlier to the marks obtained by 100 student in a psychology test, these marks are to be arranged in order, earlier ascending or the descending order. So whatever the marks we are calculated, we have to divide the whole marks into the two groups. One group is the ascending order of this median and another group is the descending order of the middle group. The middle score is, this distribution is identified as in the median. So whatever the score get for the median score, or simply the whole data divided into the two parts, one part is the lower than that value and another part is then above that value. So that type of a distribution of whole data is known as median. Though this code is This would seem easy for an odd number of the score, and in case of even number of the score of a certain procedure is followed that will be discussed when we learn how to compute median later in the units. So in the another slide we are going to calculate this is the mode value. So third calculation of the measurement of central tendency after mean or median, that is the mode. Mode is denoted by the symbol MO. Mode is the score in the distribution that occur most frequently. So simply the mode value is the value that occur more frequently, or that value have a high frequency in the whole data. That value is considered as in the mode value. Taking the example of the marks obtained by a group of 100 students in the psychology test discussed earlier, it is about the 100 students, 10 students obtained 35 marks, and 35 is the most frequently occurring value and will be termed as in the mode value. So if we are again giving the example that suppose we have marks of the 100 student in the psychology subject, and the 10 marks obtained by 35 marks obtained by the 10 student, and that marks have a high frequency, no other marks obtained by the such number of the student. So simply the 35 marks is considered as and the mode value, because the 30 marks have a high frequency in the whole data. So simply mode value provide you a high frequency of the whole data, or through we can gather the which value have a high frequency in the whole data. For instance, if there were the 10 students in the group of the 100 students who scored 47 marks, 47 value is occurred frequency is the 35, thus we will term as the mode along with the 35. In similar way, then there are the 3 mode in term of the 3 modal, and when there are the 4 or more than 4 mode, we use the term multi-modal mode value. So sometime, so we have a 3 modes, or sometime 1 mode, or sometime more than 3 modes. So we also using the multi-mode value. So simply again we are explain the mode value is the value which have a high frequency in the whole score. Suppose there are the 100 students scoring different marks in their mathematics subject, and the 35 number scored by the 10 student, and also the 47 number scored by the 10 student, and again the 57 number scored by the 10 students. So mode value is the 47, 35, 47 and the 57. So these all considered as the mode value. So simply in the measurement of central tendency, there is the mean value, there is the median value and the mode value. So in a very layman sense, I am going to explain is the mean value means the average value of the whole score, and through a single value we have an idea of the whole score or whole data of the whole population. Median value is the value that discriminating the whole data into a 2 part. One part is the lower than the median value, and the other part is the higher than the median value. So that type of value is a value considered as in the median value. And the third type of measurement of central tendency, that we are getting the value, that value have a high frequency in the whole data or the whole score or the whole population. That is explained by the 2 different examples given in this lecture. One example is related with the marks of the psychology student and the marks of the mathematics student. So simply if the marks of the psychology student in a one data, we have 100 students scoring the different marks in the psychology student. Out of 100 students, and scoring different value in the psychology. So again I am summarizing the measurement of central tendency. There are the three type of measurement of central tendency. In this lecture we are going through. One measurement is the mean, that is also called the arithmetic mean, and that also known as in the average. Second is the median, and the third is the mode value. So simply mean is, or the arithmetic mean or average is a single value for the whole data, a whole score, the whole population. Median is divided the whole population, whole data, whole score into two different parts. One part is the lower than the median value, and the another part is in the above than the median value. And the third is the mode. So mode is giving you an idea of the which value have a high frequency in the whole data, whole population and whole score. So simply mean, median, mode is very important for the point of view of the mathematics and statistics, and in a mathematics or statistical field for the further studies these three value is most prominently required in the calculation of different statistical tools or different calculation in mathematics and statistics. So next, through if the score is distributed greatly vary, then it is possible that there are no mode. Mode as such does not provide adequate characteristics of the distribution, because it just take a consideration of most frequency score and other score are not considered. So simply mode have giving a very different information regarding the data. Sometimes it provide you the, and sometimes there is no high frequency of one value repeated in the whole score. So mode is very different from the mean or median. So next slide is how to choose measurement of central tendency. The choice of measurement of central tendency will depend on, first of all, the scale of measurement that we are discussing in the first. For a nominal scale, one can compute mode but not mean or the median. So on a different scale, we have used a different measurement of central tendency. It's all depend upon which scale we are going to measure. For example, in case of male and female, the male can be coded as 1 and female can be coded as 2, or vice versa, such as a case. So we can compute frequency occurrence score that will provide us information whether there are more males or the more females. However, it is not possible to compute mean and median. This regards to ordinal scale, mean and median can be used. So on ordinal scale we are using mean and median, but on a nominal scale we are using the mode. For example, if we rank the student based on their performance in mathematical test, it is possible to find the median below and above which lie half of the rank. Mode can also be computed if more than one student gets same rank, which regards to interval scale and ratio scale, mean can be computed. So with regard to the interval scale and the ratio scale, mean can be easily computed. So simply we can say that on different scales we can use different measurement of central value or measurement, and they every central measurement have a different scopes. That scope depend upon the different scales. It another aspect that is important while making a choice with regard to which measurement of central tendency to use, and whether the data is normally distributed or no. If the data is normally distributed, we will compute mean, and if the data is not normally distributed, we will compute median and mode. So this is become a mean will not adequately represent the data when the data is not nominal distribution. But we will discuss nominal distribution in detail. So simply when data is a nominal distribution, then it is easy to use mean, but when data is not nominal distribution, then we have to use the median and mode. So simply there is one classification where we have to go for the mean value or the median value or mode value. So simply we can say that, so when data is normal distributed, then easy to calculate the mean value, but when data is not normal distributed, at that cases we have to calculate median and mode values. So here the properties, advantage and limitation, mean, median, mode. So there are certain properties, advantage and limitation of the mean, median, mode. So first we go through the properties of mean. So mean is sensitive to the actual position of each and every score in our distribution, and if another score is included in the distribution, then the mean and average of that distribution will be changes. For example, mean of the score is 4, 5, 6, 3, 2 is 4. Means first the different score is 4, 5, 4, 6, 3, 2. We add all different scores. So there are the 5 type of different score, and the total scoring is 20. So 20 divided by 5. So the value calculation is 4. So that is the total number of score in. But if we change the score to 5, 6, 4, 3, 2, 8, then the mean value will be 4.67, because the total value is 28, and 28 divided by 6. So that is the total number of score is n. So how we can go through and how we can calculate the mean value, and here we can understand the property of mean and how mean is important. Mean denotes a balance point of any distribution, and the total of the positive deviation from the mean is equal to the negative deviation from the mean. Mean is especially effective when we want to measure the central tendency to reflect the sum of the score. So this is the property of the mean. Next, the advantage of mean. The definition of mean is rigid with the quality of the good measurement of central tendency. So we simply say that the mean is very rigidly defined when the quality of measurement of central tendency, good quality of measurement of central tendency. It is not only easy to understand but also easy to calculate. So simply we can say that the calculation and understanding of mean is very easy for everyone, because everyone can simply calculate the mean if they just know the addition and the division. They can calculate the mean, and just a single value we can understand the characteristics of whole population, so it is also easy to understand. So simply we can say that the calculation and understanding of mean is one of the easiest in the whole statistical and mathematical tools or techniques. All the score in the distribution are considered when mean is computed. Further, the mathematical calculation can be carried out on the basis of mean. So there are lot of further mathematical calculation carried out on the basis of the mean. So we also understand that how mean is important for the mathematical calculation, and the fluctuation in the sampling are least likely to affect the mean. So also this is one of the importance or advantage of mean, that the sampling fluctuation does not impacting mean in a very high way. It impacting on a very less frequency or on a very less significance level. So mean flux, it is also, we can say that the mean is also important for the mathematical calculation, and it also provided you a very good inputs for the further mathematical calculation. So there are certain limitation of mean. We all know that everything have a certain advantage, and that thing is also associated with the certain limitation. So definitely mean have also certain limitation. So we go through the limitation of the mean. Outliers or the extreme value can have an impact on mean. So if the outliers or the extreme value involved in the data that impacting the mean, when there are open-end classes such as the 10 or above or below 5, mean cannot be computed. In such cases, median and mode can be computed. This is mainly because in such a distribution, midpoint cannot be determined to carry out the calculation. Next is the, if the score in the data is missing or lost or not clear, then mean cannot be computed. So also if there are certain value or the certain score is high or certain score is missing, at that situation it is tough to calculate the mean, and this is the limitation of the mean. But we can calculate measurement of central tendency through the median and mode if there is certain missing data. But if the data is missing or certain data is missing, it is not easy or it is not possible to calculate the mean. Next is the properties of the median. When compared to mean, median is less sensitive to extreme score and outlier. So simply we can say that when there is the extreme score and the outlier, in that situation median is more prominent than the mean, because in this situation mean is not possible to calculate, but we can calculate median. When a distribution is skewed or is systematically, median can be adequately used. So if the distribution is skewed, we can calculate the median, but we cannot calculate the mean value. And when the distribution is open-ended, that is, actual score at one end of the distribution is not known, and then the median can be computed. So in the open-end situation, and if the one end is not known, in that situation it is not possible to calculate mean value, but it is possible to calculate the median value. Further, the definition of the median is rigid with the quality of good measurement of the central tendency. So that is the advantage of the medians. Median is also rigid with the quality of good central tendency, or when we are going to calculate quality of good central tendency, the median is also rigid thing. This is one of the example in the median. It is easy to understand and calculate. Further, like mean, Median is also easy to understand and easy to calculate because we can understand that there is the value, median is a value that divided whole population into two parts. One part that is the lower than that value and another part is that is higher than that value. So we can understand that it is very easy to understand that, and also it is easy to calculate. Third advantage is it is not affected by outlier and extreme score in the data. When there is certain missing score in the open-end data in the initial phase or in the last data, we cannot calculate the mean value, but we can calculate median value. So simply we can say that in the outliers or the extreme score situation, we can calculate median value, but we cannot calculate the mean value. Unless the median fall in a open-end classes, it can be computed for a group data with the open-end classes. So in the open-end classes situation, we can calculate median value. And next is the in certain cases it is possible to identify median through inspection as well as graphically presentation. So in the situation of inspection as well as graphical presentation, we can also using the median value that provide you a very better understanding of the measurement of central tendency, or we can say that it will also provide the better understanding of the data or the population or the scope. Next is the limitation of the median. Also median have a certain limitation like the mean. Some statistical procedures using median are quite complex. So simply there are some statistical process and that situation we are calculating the median, that is a very complex situation. The computation of the median can be time consuming when the large data is involved, because the data need to be arranged in a order before the median is computed. So also in the situation of the large data, it is very tough to calculate the median value, because before calculating the median value we have to first arrange the data, because without arranging the data we are not able to understand that the lower part of the value of the median and the upper part of the value of the median, because median is divided the whole data into the two parts. One part is the lower than that value and another part is the above that value. That could be identified at that situation when we can arrange data in a proper manner. And in the case of the huge data or the large data situation, it is very tough, or sometimes it becomes impossible to calculate the median value. Median cannot be computed exactly when an ungrouped data is even in such cases. So we can say that also when the case of the ungrouped data situation, it is tough to calculate the median. In such cases, median is estimated as mean of the score in the middle of the distribution. So when the data is ungrouped situation, we are using the estimation of mean of the score in the middle of the situation. Next limitation is it is not based on each and every score in definition, and it can be affected by the sampling fluctuation and thus can be termed are less. So also median is fluctuated with the sampling, and when we are comparing with the mean and median, mean is not fluctuated with the sampling fluctuation, but median is fluctuated with the sampling fluctuation. Next, the properties of mode. Mode can be used with the variables that can be measured of the nominal scale. We can measure the mode, and there will be the possibility to measure the mode. Mode is easier to compute than mean or median. So also we can say that mode is easier to compute mean and median, but it is not used often because of lack of stability from one sample to the another sample, and also because of the single set of data may possible have more than one mode. So if the data have more than one mode, it is also tough to calculate, but it is easy to calculate when there is an the one mode value. And then when there is a more than one mode, then it is the mode cannot be termed as the adequately measured central tendency location. And next one is the mode is not affected by the outliers and the extreme score. So such like median, or median is also not affected with the outliers and the extreme score. Like mode is also not affected with the outliers and extreme score. So in all three measurement, if we are talking about the three measurement, median, mode and the mean. So mean is affected with the outliers and extreme score, but median and mode is not affected with the outlier and extreme score. So next is the advantage of mode. It is not only easy to comprehend and calculate, but it can also be determined by more inspection. So simply we can show that it is not easy to compare and calculate like mean or median, but it is also determined to use in the inspection, and there are immense use in a different field of businesses. It can be used to quantify as well as quantitative data. So we can say that quantitative data as well as qualitative data mode is very useful. It is not affected with the outlier and extreme score, as already we have discussed. And the next is, even if the distribution has one or more than one open-end classes, mode can easily be computed. So if there is more than one open-end classes, we can use the mode. But if the class age is open-end classes, we cannot use median. But if the more than one open-end classes, also we cannot use the mean. So, but in that situation, we can use the mode when there is one or more one open-end classes. So next is on the limitation of the mode. So as we already know, so there have a certain limitation of the mode. It is sometimes possible that the score in the data vary from each other, and such cases the data may have no modes. So if the variation in data and there is no mode in data, that is the limitation of the mode. Mode cannot be rigid defined. And next is next limitation is in statistical measurement, mode is not rigidly defined. In case of bimodal, trimodal or multimodal distribution, interpretation and comparison become difficult. So we can say that if we have one than more mode or one than more than three modes, or sometimes multiple mode distribution situation, it is tough to interpret and comparison because of the difficulties to calculate the mode. Mode is not based on the whole distribution. So simply we can say that the model value is not basing on the whole distribution. It may not be possible to compute for the mathematical procedure based on the mode. So for the further mathematical calculation like median and mode, how median and mode is important for the further mathematical calculation, mode is not as much as useful for the like median and mean. And next is the sampling fluctuation can have an impact on the mode. So if there is the fluctuation in sampling, that also affected the mode. So these are the limitation of mode. So we are going through the properties, the advantage and the limitation of mean, median, mode. So we go through this whole thing that, and we understand that uh, there are certain importance of the mean and the median, and also there are certain importance of the mode, because in a business field there are a lot of importance of the median when you are going to making a number of certs or the number of shoes or number of product in a business. At that situation also, for the designing a different SKU, stock keeping unit, in that situation mode is very high importance than the mean and median. But if you want to go for the further mathematical calculation, mean and median have a very high importance than the mode. So these are the certain advantage and disadvantage, there are the certain limitation, or there are the certain properties of all three different measurement of central tendency. So next is the computation of the different measurement of central tendency. So now, as we have developed to a fair idea about the three measurement of central tendency, we will move on the learn how to compute these all three different measurement of central tendency. While computing each of these measures, we will do so for ungrouped or group data, or ungrouped group data are explained as follows. So what type of data is known as in the ungrouped data, or what type of data known as ungrouped data? There might be the confusion in your mindset. So we are further going to explain the group data, ungrouped data. Before to know how to calculate the measurement of central tendency, first we have to go through the group data and ungrouped data. So ungrouped data. So ungrouped data, any data that has not been categorized in any way in term of an ungrouped data. For example, we have an individual who have a 25-year-old, another who have a 30-year-old, and another individual that is the 50-year-old. These are the dependent figure and not organized in any way, or they are ungrouped data. So simply this kind of, if the data are in this way, we can say that this we cannot group these all three data in a single group, and that type of data is known as ungrouped data. Another type of data is the group data. So group data that is categorized or organized in terms of as a group data. Mainly such data is organized in the frequency distribution. For example, we can have age range is 25 to 30 year, or age range of 31 to 35 year, or the 35 to the 40 years, and so on. So if we have data of this kind, that type of data is called as the group data. So when the data is in group, that is called group data. When data is in an individual format, that is called individual data. So simply there is the simple understanding, and you have to create a very simple understanding in your mind that when data is not in a group, that type of data is called a group data, ungrouped data, and when data is come within a group, that is called group data. Here, like in the example of the age range of the student between the 25 year to 30 year. So whatever the number of students come within 25 year to 30 year, that type of age of the student is called the one group of that data, and another group is the age of between the 15 year to 20 year data. So if the student come behind the age, come within the age of 15 to 20 year, that is considered as the another group of data. Like that, 5 year to 10 year, 10 year to 15 year, or 0 year to 5 years. So this type of data is called as the group data. So now we can say that there is no confusion between the group data and ungrouped data. So computation of mean in the group data. The formula of computing a mean of ungrouped data, that is m is equal to sigma x divided by n, where the m is equal to m, where the m is the mean Sigma x is the summarization of the whole score in the distribution, and n is the total number of the score. So computation of the mean for ungrouped data. The formula for the computation mean for the ungrouped data that is given in this slide. M is equal to sigma x divided n. So where the m is equal to mean, sigma x summarized for the score of the distribution, m the total number of score. Let us now compute the mean with the help of an example. The score is given in this slide, that the 58, 34, 32, 47, 74, 67, 75, 34, 39. So the total here the scope is given in the formula, the score of the 10 student, and that student related to the score of the psychological test. The step 1, first we go through step 1. In order to obtain the mean of the above data, will fill first and the marks is obtained. So mean of the above data, that first we go to the score of total data, going to the adding of the total data and the data of the marks of the 10 student. So there is a marks of the 10 student is given in this example, that is 58, 34, 32, 47, 74, 67, 35, 34, 30 and 39. So adding of all the score of 10th student, the total is 450. So step 2 is that mean equal to sigma x divided n. So sigma x is 450, and the total n is the total number of student, that is the 10. So 450 divided 10 is equal to 45. So we can say that the mean marks of the 10 student, they are getting a different mark from the psychological subject test, and the average marks they are conducting, and through that examination they got average marks is the 45. Thus the mean obtained of the above data is 45. So we can say that the 10 students average mark is 45. So by this way we can calculate the ungrouped data mean. So next slide is computation of the mean of the group data, where the formula of the computation of mean of the group data is also the formula is m is equal to sigma x divided n, where the m is the mean, sigma is the summation of the all data, and x is the midpoint of the distribution, f is the respective frequency, and n is the total number of the score, that is also related with the size of the population or the sample. So let us now compute mean with the help of an example. A class of the 30 students were given a psychological test, and the marks obtained by them were categorized into the 6 different categories. Because this is the group of data, so we are categorized 30 students in a 6 group. So the lowest marks obtained were the 10, and the highest marks obtained were the 35. So a class interval is 5 was employed. The data is given as follows. So in this example, the total number of students is 30, the number of group is 6, and the class interval is 5, and the lowest marks obtained by the student is 10, and the highest mark obtained by the student is 35. So here we are seeing in this slide the marks. There is a group of the marks is from lowest to highest. The highest marks is 35. So we taken the highest marks group is to 35 to 39, and the 30 to 34, 25 to 29, and 20 to 24, 15 to 19, and 10 to 24, 10 to 14, because here the lowest marks is the 10 marks and the highest marks is 35 marks. And the frequency is 35 to 39 student, there is the 5 frequency, and 34 to 34 is the 7 frequency, and 25 to 29 is in the 5 frequency, 20 to 24 the frequency is 6, 15 to 19 the frequency is 4, and 10 to 14 the frequency is 13. So the total frequency is 30, and that is the size of the data. And the midpoint is 37, 32, 17, 22, 17, and 12. These are the midpoint. So now we midpoint. So we are going to multiply frequency into the midpoint. So first 37 into the 5 equal to 185. Second 32 multiplied by 7. 32 is the midpoint and 7 is the number of frequencies. So equality is 224. Third midpoint is between 25 to 27. The midpoint is 27, and the frequency is 5 to 27 multiplied by 5 equal to 135. And the fourth one is the midpoint is 24 to 20, 22 or 24 is the 22, and the number of frequency is 5. Number of frequency is 6. So 22 multiplied 6 equal to 132, and the fifth one is the 15 to 19. The 15 to 19 frequency is 4, and the midpoint is 17. So 17 multiplied 4 is equal to 68, and the sixth group is 10 to 14, the frequency is 3, and midpoint is 12. So 12 multiplied 3 equal to 36. So 185, 224, 135, 132, 68, and 36. The adding of all this is the 780. So sigma fx is 780. So the computation of the mean of the group data is, the step followed for the computation of mean with the group data are as follows. First step is the data is arranged in a tabular form with the marks group in the categories with the class interval is 5. Second step is the once the category is created, the marks are entered under the frequency column based on which category they are fall under. And the third step is that we have to decide the midpoint of the category are computed with the entered under X. So midpoint is considered as in the X, and the frequency considered in the F. So multiply by X into F is equal to and divided by N, total number of frequencies. So here the next is the step 4 is fx is obtained by multiplying the frequency and the midpoint of the each category. So each category we are got different fx. So we have 6 different fx, and fifth step is the fx of all category are added to obtain the sigma fx. So in case the we have a total 6 fx, and adding all 6 fx, the sigma fx is 780. So step 6 is the formula. Formula is m equal to sigma fx divided by n. So here the n equal to 30 and sigma fx is 780. So formula is m equal to sigma fx by n. So we put fx value is 780 and number n is the 30. So 780 divided 30 is equal to 26. Thus the mean value obtained in this group data after computation is 26. So by this we can calculate the mean value of the group data. So calculating mean value of the group data, more important thing is that first create the group, and on that basis creation of the group which value fall under which group, that is called a frequency. So on the basis of the group data, we created number of frequencies that fall in a particular group, and after that we are multiplying mean value with the number of the frequency. By this way we are able to gather fx, and all fx we are adding, we are able to gather a sigma fx, and sigma fx is divided by number of frequency, that is n. So total number of frequency n. So so we can finally calculate it as per the formula m is equal to sigma fx divided by n. So here in this example, sigma fx is 780 divided by 30, that is the n. So total number is 26. So we can say that the mean value obtained by in this formula by the calculation, we can get 26, that is the mean value. Next, computation of mean value by shortcut method with the assumed mean. So there is a certain other method by this by that way we can also calculate the mean value, and that method is called as the shortcut method to calculating the mean value. In shortcut method to calculating mean value, a certain cases data is now very large and it is not possible to compute the each fx. So if the data size is very large, so it is very tough to calculate fx. In such a situation, a shortcut method will help to assume the mean that we are computing. So their mean can be computerized for the application as correct. So shortcut method is m is equal to am plus sigma fx divided by n into I. So here am is the assumed mean, sigma is the summarization, I is the class interval. So computation of the mean by the shortcut method with the assumed mean. So here sigma dash x is the midpoint of the score in the interval, f is the respective frequency of the midpoint, and is the total number of frequency or the total number of. Let us discuss the step followed by the computation of mean with the help of the example given below. So here example is given here in this slide. The computation of mean by the shortcut method with assume the mean. So here there are the different class interval. On the basis of the class interval, the value comes under the class interval, and on the basis we are finding the mean, finding the frequencies, and on the basis of frequency we are finding the mid value, and on that basis x dash is equal to x minus am. So here, so 15 fx dash is 15. First we are calling x dash. So 3, 2, 1, 0, 1 and 1 minus, because the total number is 6, means the total class interval is 6. So highest we can go through the 3, and we come to the neutral point, that is 22, 24 and less is term. So on the basis of 3, 2, 1, 0, minus 1, minus 2, we are calculating fx. So 5 multiply 3 is equal to 15, 7 multiply 2 is 14, and the 5 multiply 1 is 5, and 6 multiply 0 is 0, and 4 multiply minus 1 is minus 4, and 3 multiply with 2 is equal to minus 6. So sigma fx is 24. So here on the basis of this shortcut method, we are going to the step by step. So step 1, we will assume the mean is as 22. So assume mean is 22. Step 2, difference is obtained between each of the midpoint and assume mean, and then the same is divided by I, that is the class interval. So 5 is in the case there are each entered under the column heading as in the x dash x minus am divided by I. So x dash is assume mean, that is 22 will be 0. So step 3 is the frequency f is then multiply with the x and to obtain fx. Step 4 will all fx are added to obtain sigma fx. In the present example it is 24. So next is computation in medium for ungrouped data. So with regard of the computation of medium for ungrouped data, different procedures are followed for data that is odd or the data that is even. So odd or even data. So odd data there is a different method, and even data there is a different method. So here we are first going through the odd data. When the data is odd, the medium is computed in the following manner. The data is 58, 39, 32, 47, 74, 69, 34, 35 and 30. So n is equal to n. N is equal to 9. That is the odd data. So step 1. First the data is to be arranged in either ascending or the descending order. Will arrange the data in ascending order or descending order will to look like this. So first we arrange the data on the ascending order. 30 is the lowest point and the 74 is the highest value. So started with the ascending order 30, 32, 34, 34, 35, 47, 58, 67, 34. So on the following formula is then used to compute the median. So a median is n plus 1 divided 2. So here is n is equal to 9 plus 1. So 9 plus 1 is 10 and divided 2 is the 5. So here in this point 30, 32, 34, 35. So 35 is the fifth item. So here the fifth item is 35, and then we can say that the medium of this data is 35. So we are divided whole data into two parts. One part is lowest than the 35, another part is the highest than the 35. So 35 is considered as the median value for the odd numbers. Next is the median value for the even number. When the data is in even, the median is computed in the following manner. The 58, 34, 32, 47, 74, 67, 35, 34, 30, 39. This is the data, and data is the even data because the size of the data is 10, n is equal to 10. So step 1, first the data is to be arranged in either ascending or descending order. So we are going to arrange data in ascending order: 30, 32, 34, 34, 35, 39, 47, 58, 57, 74. So for even data, step is the first step we are arranging the data in the ascending or descending order. So we are arranging data in the ascending order. The second step is the following formula is used to compute median. So median is equal to n divided 2 for the score, or plus n divided 2 for the score plus 1 divided 2. So here the n divided 2 is the 5, and that is the 35, or the n divided 2 plus 1, that is the 6, and that we can say that the 39, 39 and divided by the 2, that is the 37. So we can say that the median is thus obtained 37 for the data is, here the data is 30, 32, 34, 35, 39, 47, 57 and the 67 and 74. So here the median value is 37. Next, the computation of median for the group data. The formula used for computation of median for the group data is as follows. MD is equal to L plus n minus n by 2 minus f divided f multiplied by I, where n is the lower limit of the median class, n is the total all the frequency, f is the sum of the frequency before the median classes, fm is the frequency within the interval upon which the median falls, and I is the class interval. So here we are going through the all values in the formula and what are the values denoted for. Let us discuss the step followed by the computation of the median with the help of the example given below. Here we are putting the example in another slide. So here example is class interval. So there are the 6 different class interval: 35 to 39, 30 to 34, 25 to 29, 20 to 24, 15 to 19, 10 to 14, and the frequency interval is 5, 7, 5, 6, 4, 3. Of the median for the group data is, the step is computing median for the group data are as follows. Step 1, the first step is to obtain n divided 2, that is 30 divided 2, or so that we obtain 1/2 of the score in the data is 15 in this case. So step 2, as the score are given in the number n is equal to 30, the median should be the between the 15 to 16 score, where we add the frequency from the above. So 15 to 16, so median will fall in the class interval of 15 to 19. Further, L that is the lower limit of the median class can be also mentioned, and the median class is 25 to 29, its lowest limit will be 24.5. So step 3, computing f, that is the sum of the frequency before the median class. In our example it would be 3, 4, 6 is equal to 3 plus 4 plus 6 is equal to 13. Next step is computation of median for the group data. Step 4 is FM is the computation, it is a frequency within the interval upon which the median fall. In the present example, the median class interval is 25 to 29, and the frequency for this class interval formula to obtain the median. So median is equal to L plus n divided 2 minus f divided fm multiply xi. So L is the lowest limit is 24.5 plus n is equal to 30 divided 2 minus 13, f is equal to 13 divided by 5, or fi is the 5. So here by that formula we can see that the median value is 26.5. Thus the median obtained is 26.5, and it is fall under the median class interval is 25 to 26. So class interval is 25 to 26 is considered the median class interval, and median value is the 26.5. Next is in the computation of mode for the group data. So let us now learn how to compute mode for an group data with the help of the following example. So here mode value score value is given. So score value is 58, 34, 32, 47, 74, 67, 35, 34, 30, 39. The mode can be calculated in the simple manner by just continuing the score that appear maximum number of time in the data. In our example, the score occurring maximum number of item is 34, that occurred twice, thus the mode is 34. So here we can calculate mode value from this data, because the occurrence of 34 is twice, or we can say that the occurrence of 34 is highest in this score. So we can say that 34 is considered as a mode value, and here in this score only single mode value is available. Next is the computation of the mode for the group data. First method. So there are the two methods which mode for the group data can be computed. So there are two methods by which method of the group data can be computed. So first method is by using the following formula: mode is equal to 3mdn minus 2m. Introduction of the measurement of central tendency, where mdn is the median and m is the mean. So 3 mdn minus 2 m. So 3 median minus 2 m equal to mode value. Here this for example, let us now compute mode with the help of the following example. So here there is in the class interval, that is interval of the 50 to 59, 10 to 49, 30 to 39, 20 to 29, 10 to 19 and 0 to 9. So class interval there are 1, 2, 3, 4, 5, 6 class interval, and the lowest value is 0 and the highest value is 50. So, and the different class interval have a different frequency value. So first class interval is 50 to 59 and their value is 5. The second class interval is 40 to 49 and the frequency value is 7. The third class interval is 30 to 39, the frequency value is 8. And the fourth class interval is 20 to 29 and frequency value is 10. And the fifth class interval is 10 to 19 and frequency value is 15. And the last or the sixth class interval is 0 to 9 and the frequency value is 5. So simply frequency value means that the score come under the interval. So in the different intervals, the highest score come within the interval is 10 to 19 and lowest interval come into the 0 to 9 and 5 to 59. On the basis of class interval, we can go to 49, that mid value is 44.5. Third class interval 30 to 39 and the mid value is 34.5. And the fourth class interval is 20 to 29 and mid value is 24.5. And the fifth class interval is 10 to 19 and mid value is 14.5. And the last class interval is 0 to 9 and the mid value is 5. On the basis of the mid value and the frequencies value, we are going to find out the fx. Frequency stands from the f and the mid value stands from the x. So fx is multiplying mid value with the frequency value. So first class interval fx is 24.5 multiplied with 5 is equal to 272.5. In the second class interval, the mid value is 44.5 multiplied by frequency value 7. That value becomes 311.5. And the third class interval is 13 to 39, mid value is 34.5 and the frequency value is 8, and we are multiplying mid value to frequency value, that value becomes 276. The fourth interval is 2029 and the mid value is 24.5, and that 24.5 multiplied by the frequency 10, the total becomes 245. And the fifth mid value is, that is come under the class interval of 14 to 14.5, and mid value is 14.5, the class interval 10 to 19, and frequency is 15. So 14.5 multiplied by 15, the fx value is 217.5, and the last mid value is 0 to 9, and last class interval is 0 to 9 and mid value is 4.5, and that 4.5 multiplied with the frequency value 5, the total value is 54.522, that is the fx value. So all fx, all 6 fx we are adding. so become a sigma fx, and the sigma fx is 1345. So here computation of the mode for the group, the formula we are going through, that is m is equal to sigma fx divided n. The use n is equal to 50. So step 1, computing the mean. Mean is equal to sigma fx divided n. That is, mean is 1370 divided 50 is the mean value is 26.9. Step 2 is computation of the median. So computation of median is L plus I by 2 minus f divided by fx multiplied by I. So that is 19.5 plus 50 divided 2 minus 20 divided 10 multiplied 10. So the total value become 24.5. So 24.5 is the median value and the mean value is 26.9. So by getting mean value and the mode value, we are going to calculate the mean value or median value. We are going to calculate the mode value. So mode value denotes for MO equal to 3mdn minus 2m. So mode is equal to 3 multiplied 24.5. 24.5 is the median value. So 3 multiplied by 24.5 minus 2 multiplied 26.9. So 26.9 is the mean value. There in this formula, mode value is calculated by using the median value and the mean value. Here our mean value is 24.5 and mean value is 26.9 and median value is 24.5. So 24.5 multiplied 3 becomes 73.5 and mean value is 26.9 multiplied 2, that become a 53.8. So 73.5 minus 53.8 become 19.7. Here the computation of the mode value is 19.7. So by this formula we can compute the mode value of the group data, and that mode value is 19.7. Seen in this slide, the mode value is 19.7, and just we are putting we are getting mode value by putting a median value and mean value, and again we are repeating the formula. The mode value equal to 3 median minus 2 mean. So 3 median is 3 multiplied by 24.5, that is the mean value, and the 2 multiplied by the mean value 26.9. So our mean value is 24.5 and median value is 24.5 and mean value is 26.9. So 24.5, that is our median value multiplied 3 becomes 73.5, and our mean value is 26.9 multiplied into 2, that is 53.8. So 73.5 minus 53.8, that is 19.7. Thus the mode computation is 19.7. We can say that the mode value is 19.7. So simply, if we want to calculate the mode value, we require to first know the median value or the mean value. On the basis of median value or the mean value, we can calculate mode value on very easily basis. Next, computation of the mode for the group data. Also we can make one observation here, that the mean obtained for our example is 26.9. The median is 24.5 and the mode is 19.7. All the three values are not close to each other, indicating that the distribution of data may not be normal, as the value do not fall in the central area of the distribution. So if the value of the mean, median and mode are the similar, then we could have said that the data is normally distributed. So simply, if the data is normal distributed, then the central measurement of central tendency is same in mean, median, mode. If the mean median mode value is different, that means we can say that data is not normally distributed. So simply here there is in the remark you have give emphasis on that. If the normal distribution, if data is normally distributed, then mean median mode value is same. If data is not normally distributed, at that situation we can say that the mean, median and mode value is differentiated. And here we can see that there is the high differences between mean, median, mode value. So data is highly highly not normally distributed. It is unnormal distribution situation. So computation of mode for the group data. Second method. In second method, computation of mode for the group data. In the second method, the computation mode of the group data, the following formula used. M0 is equal to L plus D1 minus DE plus D2 multiply Xi, where the low L is the lower limit of the class interval in which the mode may lie, called the model class interval. If in that interval mode value is lies, that is called model class interval. I known as in the class interval. Di different between the frequency of the model class and the class interval. And that is D1, and D2 is the difference between the frequency of the model class and the class interval. So there is two types of class intervals. By this example, computation of model of the group mode for the group data, the second method. So here example given. Let us discuss the step followed by the computation of mode with the help of the example given below. Example is the class interval that started with the 35 to 39, 30 to 34, 25 to 29, 20 to 24, 15 to 19, and 10 to 14. Frequency is 5, 7, 5, 6, 4, 3. These are the frequency of different frequency of the different class interval, and total number of frequencies is 30. That means the size of data is 30. So step 1, the mode is most likely to fall in the class interval 30 to 34, as that has the highest frequency is 7. Because why we are taking the class interval mode value from model class interval? Here in this class interval, the highest frequency come under 30 to 35. So 30 to 34 considered as in the model class interval where the highest frequency lies. And step is the mode is mostly likely to fall in the class interval 30 to 34, as that the highest frequency lie. Thus this is our mode class, and the lower limits of the same is L, that is the 29.5. So 29.5 is the lower limit. And the step 2, the class interval I for the example is 5. So class interval is 5. How we can get that class interval? Again we are going to the example, and that is class interval 30 to 35 to 39, 30 to 34. So everywhere there is in the class interval gap is 5. So I is considered as in the 5. And step 3 is compute D1, that is the difference between the frequency of the model class and the class interval. Below it is D2, that is the difference between the frequency of the model class and the class interval. So D1 is Fm minus Fm minus 1, and D2 is Fm minus Fm plus 1. So by this way we can calculate D1 and D2. So here where we can, Fm is the frequency of the model class, the 7 in the case of 7 cases of our example, f minus 1, that is the frequency of class interval, the model class interval 5, and f plus 1, that is the frequency interval and above the model class, that is 5 for example. So d1 is 7 minus 5 is equal to 2, and d2 is 7 minus 5 is equal to, in case of our example, the d1 d2 is 2. So we are putting values in the formula. Now let us compute the mode with the help of the formula. Formula is already given. m0 is equal to L plus d1 divided d2 plus d2 multiply xi. So 29.5, that is L, and the d1 and d2 is that is 2 and 2. So 2 divided 2 plus 2, that is 2 divided 4 multiplied by 5. So here the value comes by the computation, that is 32. So we can say that the mode value is 32 on the group data or through the second method. So by second method, group data model value is 32. We can see this is in the slide. Thank you. Any question? Good afternoon. I am Pramod Kumar Srivastava, Professor TMIT TMU. My subject is research methodology. In research methodology, today I am going to discuss on different table of contents that is related with the classification and different classification, objective of classification, method of classifications, and the steps of classification. The objective of or the outcome of this lecture is, by going through this lecture we can understand, you are able to explain the meaning of classification, state the objective and the method of classification, and describe various terms related to frequency distribution and the structured frequency distribution, construct the frequency distribution. So these are the outcome of this lecture. Next is the introduction. You have learned about the various sources and method of collecting the primary and the secondary data. As the collection data, it is raw data and you cannot interpret it and draw useful calculation. Therefore, to draw meaningful calculation on the basis of the collected data, either it is primary data or secondary data, that doesn't mean it is essential to present it in the summarized and the simple format. The classification of data help us in presenting the mass of the data in the summarized or the simple format. In this unit, you will learn the meaning, objective and different method of the classification. You will also learn about the different kind of frequency distribution and the method of constructing them. We have discussed some method of the data collection, whether the target population from where the information collected was small or the large. After collection of the data, next step is to classify the data in such a manner that becomes ready to proper presentations. The need for the proper presentation arises because of the fact that statistical data is their raw form are almost defy the comprehensive when the data are presented in easy to read form, or it can help the reader to acquire knowledge in a much shorter period of time, also facilitate the statistical analysis. A statistical table is a presentation of the number in the logical arrangement with some brief explanation to show that they are, however, before tabulating the data, it is often necessary for the first classification that are. So this slide is related with the objective. So objective of the classification is clarify the data set according to the nature of the data. So we have to classify the data according to the nature of data, construct the discrete frequency distribution for the discrete type of data, or construct the continuous frequency distribution for the continuous type of data. So generally we broadly classify data on the basis of discrete or continuous frequency. So on the basis of discrete frequency data, we using the discrete data using for the discrete frequency, or for the continuous data we are using the continuous frequency. Classify the collected data according to the class interval. Sometimes we have to classify the data according to the class interval, that is also called in the group data classification. Arrange the data into the suitable form of the table. Also we have to arrange the data into the suitable form in the data. So these are the basic objective of the classification of data. So simply according to the nature, we have to classify the data. Again the discrete data we are using the discrete frequency, or continuous data we are using the continuous frequency, and already we have to decide the classification of the class interval. On the basis of class interval we have to arrange the data, and last we can make the data into the suitable form of the table. So these are the basic objective of the classification of the data. What classification? With this unit we can understand the combination of the classification and presentation in the tabulation form of a given data. After collection, classification is the next step in processing the collected data. Classification means growing of a related fact into a different classes. Information is one class differ from those of the other class with respect to the some characteristic. Sorting particular according to one basis of the classification, and then on another basis is called the cross classification. This process can be repeated as many as the possible sources of classification are there. So classification of the data is a function very similar to the sorting letter of the post office. Let us example, or let us we can explain it in the further consideration of the situation where the university receive application of candidate for the filling of some post in the various department or the discipline. So on the basis of various department and discipline we are sorting the whole data, and on a proper or homogeneous department we are getting a homogeneous group. The application received for the post in the university are sorted according to the department or discipline to which they are pertained. So simply we are classifying whatever the application coming to the university for the particular post or the particular department, or the different post and the different department. So according to the department or discipline to which they are pertinent, for which discipline they are coming to. It is well known that the application collection in the office are sorted into different blocks, department or discipline wise, that is in accordance with their destination as the social science, engineering, basic science, etc. They are then put in a separate belongingness, and each containing application with a common characteristic which via having the same discipline. So classification of the statistical data is comparable to the categories process. The process of classification gives distinctions to important information gathered while dropping necessary fact, enable comparison and the statistical treatment of the material collected. Now the question may arise in your mind that how collected data is classified. The answer in this question is given under the heading type of classification as discussed below. So simply we are discussing how the classification means classification is categorization of the data as per the requirement, as per the need. So whatever the confusion in your mind, we are going to sort out that confusion created in your mind, what actually classification and what do you mean or what do you understand by the classification. So generally here in this slide you can see that broadly data can be classified under the following categories. The category pertain with geographical classification, chronological classification, qualitative classification and quantitative classification. These are the major part of the classification, and this is not only part of the classification, but significantly we are classify the data on following way. So first going through geographical classification. In geographical classification, data are classified on the basis of location, region, country wise, state wise, district wise, village wise, urban or rural data. So these all classification come under the head of geographical classification. So simply the data classified according to the geography, that is called geographical classification. So here I am also repeating that, and there might not be any confusion related with the geographical classification. You have to focus on if data is classified according to the geography, that is called geographical classification. Data classified if we are working for the entire nation, the data is classified on the nation-wide data, then that data classified on the different state data is classified on the different district data is classified on the different block data classified on the different village. So these are the classification come under the geographical classification. For example, if we present a data recording production of a sugar cane or the production of the wheat or the production of rice in view of the for maintaining the region in India, and which region giving you a what amount of the production of the sugar cane or what amount of the production of the rice or the wheat, on that basis we are classifying the data. So for that we have collected the data on the very lower level of data. First we have collecting the data from village level data, on that village level data district, and district basis the state basis is the country, and the whole state data accumulated, that we can say that the production of the wheat in India, the production of the sugar cane in India, or the production of the rice in India. On that basis we also calculate the highest production of the wheat in which state, highest production of rice in which state, or the highest production of sugar cane in which state. Also we can are able to say that which district giving you highest percentage of sugarcane production, or the highest percentage of the wheat production, or highest percentage of the rice production. So these are the classification in a first way. So geographical classification is usually listed in the alphabetical order for each easy reference. So we are using alphabetical order of the geographical classification for the easy reference. Item may also be listed by size of the emphasis, the magnitude of the area under consideration, such as ranking the states based on the population. Normally the reference table and the first approach listed in the alphabetical order is as follows. So here we are going to the classifying the production of wheat. So we are divided the wheat production in the four region. The eastern region, the state come under the eastern part of the country, or the northern region, the states come under the northern part of the country, or the southern region, the southern state of the country, and the western region is the western state of the country. On that we are putting that the production of wheat in the eastern region, uh, the production of wheat in the northern region, or the production of the wheat in the southern region, or production of the wheat in the western region. On that basis we are classified wheat production on the four different regions. So this type of classification is geographical classification. So simply again I am repeating that if we are classifying the data on the basis of geography, that is called geographical classification. Data might be related with anything. Data might be related with the agriculture production, data might be related with the population, data might be related with the income data, data might be related with the expenditure data, or the data might be related with the literacy rate. So which state or which district have a high literacy rate. So that all data related with the geographical categorization, and that geographical categorization is known as geographical classification. So after geographical classification, other classification is the chronological classification. You are seeing the chronological classification in this slide. So classification of the data observed over a period of time, that is known as the chronological classification. So if data related with the time, that is called after the time period of data, that is called chronological data. So classification of time period of data, that is called chronological classification. For example, let us consider the profit figure of the company as shown below of the year from 2001 to 2010. So that is the chronology of 2001 to 2010, that is the 10-year chronology, and the profit figure of the company of that chronological classification, what company profit amount in 2001, what profit amount in 2002, the amount in 2003, or amount in 2004 or 2005, 2006, 2007. So different year in 2001 to 2010, and different annual profit of that company. And if you are putting the information of the annual profitability of company, that type of information is called as the chronological classification. So simply we can say that the chronological classification is related with the classification on the basis of time. So on the basis of time, if we are classified the data, that type of data is called a chronological classification. Time series data are usually listed in the chronological classification. Normally the ascending order of the time period, like 2001, 2, 3, 4, 5, 6, 7, that is the ascending order, or the descending order chronological classification 2010, 2009, 2008, 2007, 2006, 2005, 2004, 2002, 2001. That is the ascending order chronological classification. So data on the basis of time period classification, that is called chronological classification. That chronological classification should be ascending order, or that might be the descending order chronological classification. When the major emphasis fall on the most recent event, the reserved time order may be used. So here in this slide we go through the chronological classification, and in the chronological classification putting the example of the profit of the company from 2011 to 10, and that chronological classification called as the ascending order chronological classification, because data started with the 2001 and goes to the 2010. So that is the ascending order chronological classification. In that ascending order chronological classification, from this table we go through that in 2001 company profitability is 20 crore, and 2002 to company profit is 21,000, 2003 company profit is 10,000, 2004 company profit is 18,000, 2005 it become 15,000, 2006 it become 12,000, 2007 it is 25,000, again 2008 it is 14,000, 2009 it is 19,000, and 2010 23,000. So you are saying that the profitability figure is very zigzag figure. Sometime company have a high profit in 2001 or 2002, but in 2003, 2004 or 2005 or 2006 the company is getting profit, means the data is lower down, and again in 2007 company is getting good profit, but 2008, 9 and 10 company's figure is not good. So by this chronological classification we can understand that zigzag figure of the company profitability and also we are seeing that the company profit is up and down. Company is not getting a smooth profit on a positive manner or not a negative manner. So simply, again I am repeating that chronological classification means classification on the basis of time period. That is called chronological classification. Chronological classification might be the ascending order or descending order. When we are going through a lower time period to higher time period, that is called ascending order. When higher time period to lower time period, that is called descending order. If the data from the 2001 to 2010, that type of chronological classification is called as in the ascending order chronological classification. If data is 2010 to 2001, we are calling the chronological classification on the basis of the descending order. Next type of classification is quantitative classification. So quantitative classification refers to the classification of data according to the some characteristics that can be measured or numerically, such as in the height, weight, income, age, scale, etc. So simply we can say that quantitative classification is type of classification on the basis of numerical, or we can measure that classification. So we can measure the height, weight, income, length, the age, the sales figure. So that type of classification is called a quantitative classification. And for example, the employee of any institute may be classified according to their pay scale are as follow. So if we are talking about the classification of employee in any organization, that classification on the basis of their pay scale, on which scale or which income they are fall within, and that classification is a particular group of classifications. So here by this table we can understand that classification, a quantitative classification of the employee. So employee of 840 employee in a particular organization, and they are classified on the basis of pay scale. So pay scale are 9300 to 34,800 pay scale group. Second pay scale group is 15,600 to 39,100. Third pay scale group is 37,400 to 67,000. So on the basis of that pay scale, 4,000 out of 840 employees, 467 employees come under the scale of 9300 to 34,800, and 250 employees come under the pay scale of 15,600 to 39,100, and just 158 employees out of 840 employees, the pay scale is or pay band is 37,400 to 67,000. So we can say that that type of classification is a quantitative classification. Simply we can say that the quantitative classification is a type of classification that classification we can use the numerical value that is measurable on the basis of numerical value. So there are different way to classify quantitative data. We can classify data on the pay scale basis, we can classify data on the income, or classify on age basis or the height basis. So different basis we can classify the data, and that type of data classification is called quantitative data classification. Last one is quantitative data classification is a combination of two elements, namely variable, the pay scale. Here the variable is pay scale and second one is the frequency. So in the above example there are 467 employee getting a salary or pay band or pay scale is 93,000 to 9300 to 34,800. 215 employee are getting salary according to the pay scale 15,600 to 39,100, and so on. So quantitative classification give birth to a frequency distribution. So the concept of frequency distribution comes through the quantitative classification. So what we are talking about, the frequency distribution, it's a part of the quantitative classification. On the basis of the quantitative classification, we create an interval or the data coming under that interval. That data is the frequency of that interval. Next is the qualitative classification. In qualitative classification, data are classified on the basis of some attribute or qualitative characters such as gender, sex, color of the hair, literacy, religion, etc. So on the basis of quality, on the basis of attributes, on the basis of behavior, when we are classifying the data, that type of classification is called as qualitative classification. You should note that in this type of classification, the attributes under the study cannot be measured quantitative. One can only count it according to the presence or absence among the individual of the population under study. For example, in the case of color blindness, we may find out as how many persons are color blind in a given population. So it is not possible to measure the degree of color blindness in each cases. Thus, when only one attribute is studied, the two classes are formed. One are the processing the attribute and other are not processing the attribute. So quantitative classification, we are just going through the yes or no. Means simply if I am talking about or asking about the color blindness, here we are not asking about the degree of color blindness. In that situation, if the person is color blind or not. So by this way we are classifying yes or no. This type of classification known as a simple classification. For example, the population under study may be divided into two categories based on the characteristics of the color blindness. So this color blindness classified into the two categories. So here we are seeing in this slide that the whole population, that is the qualitative classification. So the whole population divided into the person with the color blind or person without the color blind. So there is two classification of the quantitative data. So quantitative classification is a similar manner. We may classify population of a colony on the basis of the educational qualification, employee, sex, etc. This type of classification where two or by two classes are found is called as the two-fold autonomous classification. Means when we are classified two type of classification, It is formed as only two classification, that type of the dictonomous classification. We further divide the data on the basis of some other attribute, with those attribute is known as the manifold classification. For example, we may first divided the population into men and women on the basis of the attributes, that is called the gender or the sex, that is classified into the two division or the subdivided into the literate or illiterate person. That is also the dictonomous type of classification, where we only classify into the population into the two parts. Here in this table you can see that the qualitative classification, the population, first men or women, the first stage. The second stage is the literate or illiterate men or women, and the third stage is the implied and unimplied level. So here we are classifying the quantitative data on the multiple stages. First stage is a gender basis stage, second step is the literacy basis step, and the third basis is the employment basis step. So on three different bases of the state, so we are classify the data. So that is the classification of data on the quantitative basis data, and this classification is the three step classification. Thank you.